Hi, this is Hans from Redcatch. In this video, I introduce you to a new RTK 360 camera add-on. These 4 steps are required, and in the end you receive a directly georeferenced 3D model. So let's start with the first one. Unpack your camera and get familiar with the parts. You receive the housing where you put your camera in. You need a selfie stick to get the camera to a certain height and some cables to connect with your smartphone. Now it's time to assemble the parts. So put your camera inside the housing and gently tighten it by screwing in the selfie stick. Now connect the USB cables to your smartphone and start RTK camera app. The app is required to connect to your entry broadcaster to receive RTK correction data. So let's go outside and take some photos. If your aim is to receive a 3D model using photogrammetry technique, you have to follow some guidelines to capture the photos. In this case, I'm taking photos every 3 steps. This will ensure that I have enough overlap to create a 3D model afterwards. Back in the office, we have to geotag the photos. We are using the path recorded on the smartphone and the images recorded in the camera. Included in our package is a small piece of software which performs the geotagging of the images and either writes a CSV file for external usage or directly the geo information into EXIF data. So now let's go into photogrammetry software and create 3D models. Here I'm using Agisoft Metaship and already imported the cameras with the geotag information, so positions and accuracy tags are already there. Don't forget to switch the camera model from frame to spherical, so that the alignment can be performed. So the first step in Agisoft is the alignment process. Choose high to use the full resolution of the image and adapt some advanced parameters. Mainly increase the number of points searched and increase the number of tie points, so you will get a better result. This will now take a while, so I'll skip the processing step and go directly to the result of the alignment. Now you can see those spheres are the camera positions, and you see the tie points. There are many tie points on the road and on the building's wall too. Let's do some accuracy analysis, and you will see that for the image coordinates, the overall accuracy is at centimeter level. So the next step is the mesh generation. We're using a depth maps mesh. It was introduced in, I guess, Agisoft 1.6. We're using ultra high, means we'd like to receive a 3D point from every pixel in the image, and we do a moderate filtering. This will take some time, so I jump directly to the result, a 3D mesh where each triangle has a RGB value from the images. The mesh is quite detailed, and even the road surface or the walls are very detailed. I'm using the sample points feature to extract the point cloud from the mesh. This gives great results and is quite fast too. You can use this point cloud in any other software for your analysis or to digitize the geometry. Back to mesh, you can even create a texture and build photorealistic 3D models. You can even create an orthophoto from your 360-degree spherical images. Depending on the workflow, you choose the orthophoto based on the EM or the mesh, and you receive a very detailed, high-resolution orthophoto. Export the orthophoto to any GIS or CAD software, and you can start digitizing or do your analysis. Our RTK add-on for 360-degree cameras is a great tool for terrestrial photogrammetry. It perfectly fits the needs for surveying and mapping. And the RTK GNSS allows a direct georeferencing, so without the need for GCPs. Agisoft, Pix4D or OpenDroneMapper are a good choice for processing spherical cameras to 3D models. We at RedCatch provide trainings and support, so if you are struggling or you have questions, just contact us. You can visit our website to download some example datas. In our webshop you can buy your device. There are several packages available, and I'm pretty sure one of those will fit your needs. Thanks for watching, hope you enjoyed, and see you soon. Bye!